Today we will discuss uncontrolled rectifier. What is the rectifier? Rectifier is nothing but a AC to DC converter. So this rectifier can be single phase or three phase, 50 Hz or 60 Hz system. When you have a rectifier circuit and you will get the output as a DC, but DC contains some ripples. This ripples is nothing but unwanted portion of the DC voltage. And when you put a filter and you can connect through the filter to the load, pure DC, you can fed the load. So this filter is exactly like in our house we get a water filter. So we get the raw water and we filter out and we take the water. So exactly similarly this is also. And diode rectifiers are unidirectional converter. They are called unidirectional because power flow in the one direction. You can see here the arrows are in one direction. There are a lot of applications in the steel rolling mill, paper mill, printing press and textile mill, using DC motor drive also, high voltage DC, battery charger circuit, traction system and interruptible power supplies, electroplating and electrolysis. There are different kind of rectifiers. One is called uncontrolled rectifier, where you don't have control. As soon as the device is forward biased, the device will be turned on. That is like a diode. And second one is half control semi-converter circuit, where you can control that by controlling the output by varying the firing angle from 0 to 180, but we cannot get the two polarity. And the fully controlled rectifiers are the output can be controlled by controlling the firing angle from 0 to 180 degree, and the output can be reversed. There are two kind of half and full wave rectifier. A single phase I can show you. This one is our single phase and this is our three phase, and both is having half wave and full wave rectification. So what is the half wave rectification? When we rectify half of you can see here, this is a half wave rectifier, and you get the positive half of the voltage waveform and negative half is blocked. Similarly, in the full wave rectifier also, you can see that all the waveforms are rectified, and you can see that in the positive side there are waveforms both. But before analyzing the rectifier circuit, we have few assumptions. Those assumptions are that forward voltage drop, reverse and forward leakage current in the diode and thyristor are neglected. There is no energy storage element in the rectifier, and the pulse which we applied, they are sufficient to switch on the appropriate thyristor. And for a single phase, we go up to 10 kilowatt. Single phase rectifier can be utilized up to 10 kilowatt power rating, and above that we can go for the three phase bridge rectifiers. So today we will discuss the single phase half wave uncontrolled rectifier with resistive load. You can see here, this is our source voltage and this is our diode bridge, and this is our I0 or the load current, and a resistance is connected here as a load here load voltage is V0. So when you apply a voltage Vm sin omega t in the input side, you can see the first figure is our Vm sin omega t, and as soon as there is a forward bias or positive voltage, you can see that the diode is turned on and it will be like a short circuited, and the Vs will appear across the V0. So and then when there is a negative voltage, as soon as there is negative voltage, there is a reverse bias, which the diode will be open circuited and there will be no current in this. So this is like a open circuited and diode is reverse bias. So you can see here this is a 0 and then it is again. So if you see here, the load current is Vs divided V naught divided by R, which is nothing but Vs by R, which is exactly same curve. And if you see the output voltage V naught, or the average of the output voltage by using 1 by 2 pi 0 to pi and Vs omega d omega t. So if you put the values, you will get, this is our derivation, and you can get the value of Vm by pi. And what is the current? Current is V naught by R, which is equal to Vm by pi R. So the output DC power is nothing but V naught into I naught, which is nothing but equal to V square by R. And if you want to find the RMS value of this voltage, we can get by using this equation. VO RMS is 1 by 2 pi 0 to pi V square into d omega root mean square. And by putting the value of Vs here, you will get this is the equation, which you will get Vm by 2. So the RMS value of the load current, or the load current RMS value is VO RMS by R, which is Im or Vm by divided by 2R. So the output AC power is given by PAC is VO into IO RMS, which is nothing but VO square RMS by this one, and this is our output AC power. So output DC power is given this one, and output AC power is given this one. So efficiency of the converter is output DC divided by the AC power, okay, PAC. That is called the converter efficiency. And the output AC component has two values. One is, I told, DC value plus ripple. So that is nothing but a DC value and the AC component or the ripple. So the RMS value of AC component of the voltage VAC is nothing but VO RMS minus VDC square, or the V output average square, so root over. So form factor is the shape of the voltage. So that is nothing but VO RMS divided by VAC. So the ripple factor is the measure of the ripple content or the degree of distortion in the rectifier voltage waveform, and which can be calculated as converter. So ripple factor is the RMS value of AC current divided by the average value. So VAC by V naught, or this is called VO RMS minus VO square divided by VO. And transformer utilization factor is defined as the output DC power divided by input. The VSIS is the secondary of the transformer voltage, okay, Vs into Is. So displacement factor is cos phi, and the phi is the phase angle of the fundamental component of the input current and the voltage. So when we have a non-sinusoidal wave and you need to find out the Fourier analysis, then find out what is the fundamental component and what is the difference between the fundamental component of the current and the voltage. That is called the displacement factor. And the harmonic factor is the Is square minus I1, the fundamental component of the RMS component of the input current divided by I1. So power factor is nothing but AC output power divided by input volt ampere, Sin. So we will take one example here, that a single phase source is 240 volt 50 hertz. supplies load of 100 ohm, and calculate the average and RMS value of the load current and the power dissipation. So if you see here, this is the I naught is our load current formula. Already we know Vm by pi r, which is 1.08 ampere, and IORMS is nothing but Vm by 2r, which is 1.7 ampere, and PAC is around 289 watt, and S in is nothing but 240 into 1.7, which is 408 watt, and power factor is PAC by SN, which is equal to 0.7. Ripple factor is 1.21. So if you see that second part, it asks what must be the rating of the diode. So the value of 1.21 for the half wave rectification is large, since the ideal value of the ripple factor should be 0 for the output DC voltage, and that is why the peak reverse voltage or Vm is nothing but root 2 into 240, which is 339. So we should choose the current is 1.21, so we choose the current as 1.7 ampere. They are around 2 ampere diode rating current, and we choose the 400 volt, so which is the rating of the rectifier circuit. So the analysis that output wave contains an AC component ripple, and DC component is only 32% in this single phase half wave rectifier, and the peak voltage applied, so low DC output voltage, high ripple, so this rectifier we do not use practically, so limited to low voltage application only. Thank you.